Today we're going to discuss the topic of frequency distributions, which is an important aspect of organizing and summarizing statistical data, because frequency distributions give us the capability of visualizing the distribution of a large amount of statistical data. We accomplish this by grouping our data into categories called class intervals. Each class interval has a lower class limit and an upper class limit. It has class boundaries, which is the midpoint between each class and the next class. We have class midpoints, the middle of each class, and each class has a class width, which in the example we're going to be using is a class width of 20, but for any given class interval, the class widths need to be the same for each class. In our example, we're going to show you an example of IQ scores for which the lower class limit of the third class will be 90. The upper class limit of the second class will be 89. The class boundary between class 3 and class 4 is 109.5. The class midpoint for the first class is 59.5, and the class width of each class for this distribution is 20. So here we have our table giving you the classes from 50 to 69, 70 to 89, 90 to 109, etc., along with the frequencies of each class. In this class, if you add the frequencies, you get the sample size, which for this example is 1,000. The relative frequency is the percentage of the total number of observations within each class. For example, the first class has a frequency of 24. 24 divided by 1,000 gives us 0.024, or 2.4%, the total number of observations in that class. If we repeat that for each of the class intervals, we get the percentage of observations in each class, which ultimately will add up to 1 or 100%. In the case of the cumulative frequency, that represents the cumulative total within each class interval. The cumulative total is the number of observations in a given class plus all previous classes. So, for the first class interval, we have a cumulative total of 24, because that's the number of observations in that class interval, and there are no previous class intervals. For the second one, you have a frequency of 228. 228 plus the 24 in the previous classes give us a total of 252. The cumulative relative frequency does the same thing with the relative frequency column. The class midpoint is now identified for each class. For the class 50 to 69, our midpoint is 59.5, 59.5, that's 50 plus 69 divided by 2. We do the same thing for each following class, and we get 79.5, 99.5, and so on. Each class midpoint should be 20 larger than the previous one, since our class width in this example is 20. Let us go to the calculator now and take a look at how this example problem will graph. We're going to go to the stat plot function, and we're going to make sure that we have the plot function turned on. We're going to make sure that we have the type of plot that we want selected. We have the midpoint set to list 1. We have the frequencies set to list 2. So at this point, we're going to go to Zoom 9. And we have our plot, which we can change the bar widths if we wish. And let's take a look at the next slide. You'll see the plot that we came up with in the TI-83 on the bottom of your screen, and you'll see the histogram from a similar function in Microsoft Excel in the upper part of the screen.